Let's try again in example number 5, another example where the leading coefficient of the quadratic is other than 1. So here's my example number 5. We would like to solve again using the quadratic, using the factoring method. Now, I have x plus 2 equals 6x squared. No. So in this problem, obviously, we need to move the terms around so that we need to bring all the terms to one side and leaving a 0 on the other hand side. However, now there's something I should have mentioned. Of course, you can choose your own side to move the terms to. However, it would be always a clever idea. It would always be wiser to move all the terms, to the side that has the positive leading term. Now, what I notice here is my leading terms of the x squared is already a positive 6x squared on the right hand side. So I would like to move all my other terms on the opposite side to the same side as my leading term. So the point is, I would like to move the terms in a way that I'm keeping my x squared term positive. And so that means I'm going to have to subtract x and subtract 2 from both sides. And that's going to give me 0 equals 6x squared minus x minus 2. Okay, so once again, the whole point is that with our starting equations, okay, x plus 2 equals 6x squared. I still have to move the terms around to leave a 0 on one side. However, the way we're moving it is we want to move in a way that we want to keep the positive leading term, 6x squared. Okay, so that's why I subtract x from both sides and I subtract 2 from both sides. And what I can see here is that I have 6x squared minus x minus 2 equals 0. Now, if you're not comfortable of seeing the 0 on the left-hand side and other terms on the right-hand side, this equation is the same as 6x squared minus x minus 2 equals 0. So now it makes it a little easier to understand about the equation, isn't it? And so at this point, once again, we have another equation similar to what we had earlier, leading coefficient other than 1. So to factor this, once again, I encourage you to look back into the video lessons where I showed you how to do factoring with these quadratic expressions. Now, I would have to do 3x minus 2 and 2x plus 1. That is how I factor x squared minus x minus 2 into these two factors. And then setting it equal to 0. So at this point here, once I can turn all my quadratic equation into two separate factors, I can just simply take each factor and set it equal to 0. 2x plus 1 equals 0. So now my next step here is to solve for these two independent little sub-equations. So the first one I'm going to do adding 2 to both sides, and that leaves me 3x equals 2. And then I'm dividing 3 from both sides. That gives me x equals 2/3. So here it goes, my first solutions. Now, my next one, on the other hand side, I can subtract 1 from both sides, and I have 2x equals negative 1, and then dividing both sides by 2, I'm going to get x equals negative 1/2. And here it goes, my second solutions for the quadratic equation. Okay. Example number 6. Let's try a couple more examples of factoring problem. Once again, we want to solve the equation 6x squared equals 3x. Now, you might feel a little surprised. Now, is this a quadratic equation? Yes, it is. It's still a quadratic equation. For the reason being, I do have an x squared term in here. Okay? The x squared term is my largest term, my largest power term. And once again, I do notice that I need to move the terms around because I do not have a 0 on one side and other terms on the other side. So what I need to do, and once again, we want to move in a way that I want to keep my leading coefficient positive. So my leading coefficient as far as this point is already positive, so I need to subtract 3x. Okay? And that's going to leave me 6x squared minus 3x equals 0. So now this time I have a quadratic equation, only 2 terms. The constant term is missing. Now, once again, after you review your factoring skills, this equation here, there are only two terms, so the only way that we can factor this equation here is to just simply find the GCF, the greatest common factor. And what I can see is that throughout the two terms on the left-hand side here, my GCF would be a 3x. So I am going to factor out 3x, and then what leaves behind in parentheses is going to be 2x minus 1 equals 0. Okay, and so this is how I solve how I factor my equation. So what I can have here is going to be, now once again, you can think about, you have two independent factors, once again 3x and times with a 2x minus 1. So what you can do, take 3x, setting it equal to 0. You take 2x minus 1, set it equal to 0. And then we solve each of these equations here independently. So for the first little sub-equation, I can divide both sides by 3, and I'm ending up with x equals 0. And here it goes, my first solution. Now for the second one, I'm going to have to add 1 to both sides. That leaves me 2x equals 1. And then dividing both sides by 2, that gives me x equals 1/2. And here I have my second solution for my quadratic equation. Example number 7, and this is the last one for in our solving by factoring technique here. So I have 3x squared minus 48 equals to 0. So now with this quadratic equation, once again, the reason I know it's a quadratic equation is because I have an x squared term, okay, and any other term has power lower than the square power. And so now, to factor this equation, what I can do here is that I see that the only GCF I have in this problem is a 3. So I'm going to factor out the 3, and then I have x squared minus 60 equals 0. Now, I have mentioned this in class, but I might have not mentioned this story in this video lesson. But then when you factor, the point is you need to completely factor. So here even though you factor out the 3 and you have an x squared minus 16, but then x squared minus 16 can be factored further. So to completely factor the left-hand side, x squared minus 16, whichever part I'm underlining, you can also do, I recognize this as x squared minus 16, I recognize that as the x squared minus 4 squared. That's what 16 is. And so x squared minus 4 squared, I recognize that as a difference of 2 squares. So using the identity for the difference of 2 squares, I can factor 16 x squared minus 16 into x minus 4 and x plus 4. And this is the factor form for x squared minus 16. And then my other factor of 3 is in front, equal to 0. At this point, I actually have 3 factors. But then notice, one factor, 3 right here, is a constant. And a constant can never be equal to 0. So you can just simply cancel it away from both sides. Okay? So my equation really, it turns out to be x minus 4 as one factor times x plus 4 as the other factor equal to 0. You don't have to worry about the 3. And so now what I can do here is take the 2 remaining factors, x minus 4, set it equal to 0. X plus 4, set it equal to 0. So I have, now at this point, my 2 independent equations. I'm going to add 4 from both sides for my first equation. Here I have x equals 4. There it goes, my first equation, my first solution. For the second equation, subtracting 4 from both sides. And here it goes, x equals negative 4. And that's my second solution.